Welcome back to part 2 of graphing systems of equations. Here we're going to look at a couple different special systems of equations. Let's continue, and we're going to graph these two equations on the coordinate plane to our right. Y equals 2x minus 3. We're going to start down here at negative 3, and the slope is positive 2. So we rise 2 and run 1. Remember, slope is always a fraction, 2 over 1. Sketch our line. You'd probably want to try to use a ruler. I can't really do that when I'm doing this on the computer. So y equals 2x plus 1. We're going to start here, and again we'll rise 2 and run 1. And what you notice with these two lines is that they never intersect. These two lines are parallel lines. And parallel lines, when you get a set of parallel lines, the solution is no solution, because these two lines will never intersect. Parallel lines, if you're asked to find the solution, is always no solution. Let's take a look at the next example. Here we've got our first equation, y equals 1/3 x plus 2. We're going to graph that. Up 1 over 3. Our second equation is in what's called standard form, so we need to solve it for y. So we're going to subtract x from both sides and divide by negative 3. So we find that our equation is y equals positive 1/3 x, because a negative divided by a negative is a positive, plus 2. Now, do you notice that this equation is exactly the same as the first equation? So when we graph this equation, it lies right on top of the other equation. That's why I did this in separate colors. So the blue line and the red line share an infinite number of points. Okay, it's not just one place where they intersect, but they actually lie right on top of each other. So this would be said to have infinitely many solutions. It's not all real numbers. All real numbers would be everything on the coordinate plane. Okay, infinitely many solutions. There's QCC calling me. Infinitely many solutions means that they're just along that line. The textbook on page 271 kind of refers to these three different types of solutions. Okay, when lines intersect at one place, they're said to be consistent and independent. Okay, and I know this particular thing is on the final exam, so it's something you do want to study for. Okay, if there is a solution at all, it's a consistent system. If there's no solution, the system would be inconsistent. Okay, these two also have are independent equations because they each have separate lines, whereas the one where it has an infinite number of solutions, these equations are said to be dependent. Okay, so this is our talk on special systems and graphing them, and I look forward to seeing you back for substitution.